Welcome to Math 154 videos. This video is going to talk about antiderivatives. And an antiderivative we can just think of as sort of the reverse of taking the derivative. So now it's if we have a function, what function do we derive to get to the function we have? So we're going to denote the most general antiderivative right now by capital F of x. And so if we look at this example here, this first term, 3e to the x, well, to find the antiderivative, we need to think about what do we take the derivative of to get 3e to the x. Well, the derivative of e to the x is equal to e to the x. So the derivative of 3e to the x is 3e to the x. So really, that stays the same. That's just because when we take the derivative of e to the x, it stays the same. Now, secant squared of x. What function has the derivative secant squared of x? That turns out to be tangent of x. So the antiderivative for secant squared of x is tangent of x. So now we want to think about the x squared term. So for x squared, we need to basically do a reverse of the power rule in order to arrive at the function whose derivative is x squared. So it turns out, in general, the antiderivative of x to the n is just going to be x to the n plus 1 divided by n plus 1. And you can check that by, if we take the derivative, we would multiply by n plus 1 out in the front, then it would cancel out, and we would get x to the n. So that actually checks out. So here our n is 2, right? So x to the n plus 1 is x to the 2 plus 1, which is x cubed. And then we're going to divide that by 3. Now, since we want the most general antiderivative, we're going to need to add a constant. And that's just because if we take the derivative of a constant, we're going to get 0. So we could have had a constant there before we differentiated, but we're not sure what that constant is because we weren't given any initial conditions. So this is going to be our final antiderivative. Now, if we wanted to, we could check this by taking the derivative and seeing if we get f of x back. So the derivative of capital F of x is little f of x, and the derivative of 3e to the x is 3e to the x. The derivative of tangent is secant squared, and the derivative of x cubed over 3, we're going to multiply the 3 out in front, and we have x. We knock the power down by 1, so that's 2. The derivative of the constant is 0, so this n part becomes x squared. And that's what we had up at the top, 3e to the x plus secant squared x plus x squared. So we found the correct antiderivative. Alright, so now we're going to look at an example where they give us a derivative and we want to find the original function, but we have this over here, which is called an initial condition. So that tells us f of some number, and we can use that to find our constant. So we're going to go ahead and take the antiderivative of this function. So that's going to give us f of x. And we need to think about the 2 is just a constant, so it can just stay there. Now, if we take out the 2, this is really 2 times 1 over x. So what function do we take the derivative of to get 1 over x? If you think about it for a while, you'll realize it's the natural log of x. So really, this is the natural log of x. And we're putting the absolute values there because we can't take the natural log of a negative number, so we need to make sure that what's inside the natural log function is actually positive. and then we're going to add a constant to it. Now if you notice, they gave us in the problem that all of our x are less than 0. So since all of the x are less than 0, we can replace this absolute value of x with a negative x. That's because when we take the negative of a negative number, we get a positive number. So really the absolute value of x is equal to negative x when x is less than 0. Okay, and you can check that by plugging in a negative number, say negative 2. Well, negative times a negative 2 is a positive 2. So it does the same thing as the absolute value function. So this is okay. Now they give us f of negative 1 is 7. So we can use that to figure out what this constant is. So f of negative 1 is equal to 2 times the natural log of negative 1 plus our constant. So 7 is equal to twice times the natural log of 1 plus our constant. Well, the natural log of 1 is 0, so we get 7 equals our constant. So then our original function becomes f of x is equal to 2 times the natural log of negative x plus 7, because 7 was our constant, and that is our original function f, whose derivative is 2 over x.